All right. Be quiet. Be quiet. We're going to get started. We're on page 139. So it says a handrail runs alongside a stairway. As the horizontal distance from the bottom of the stairway changes, the height of the handrail changes. So what they're saying is that there's a handrail that goes up steps. Actually, I should probably make it, it's probably closer to this, the slope of the line. So this is a handrail that goes up some steps. Okay, like this. And what they're measuring is the horizontal distance. This is the horizontal distance versus the height. Okay. Now, I use this example a lot when we talk about slope. I say that people say, well, when do you use this in the real world? Interesting conversation I had this weekend. I came to the school for the pageant, and a mom came up to me and she said, hello, Mr. Adams. I hear you're a teacher here. What do you teach? I said, math. And she got angry. She said, I didn't like algebra. I've never used it before in my life.
Oh yeah, I like that, Mom. She's cool.
And then I just said, well, you know, it's okay. But this is something that contractors use every day. The reason your stairs work out the way that they work out, if anybody has a house that has stairs, there's a rise over run. So they measure the horizontal distance and they measure the vertical distance that you need to transverse. You need to go up to the second floor or go down to the basement. And they say, okay, how far, what's the horizontal distance? And it's a rise over run. And so then the carpenters or contractors, whatever term you want to use, they're going to measure a rise over run. So you could think of this as stair steps, which it is in this case. But anyways, it says show the relationship is linear and then find the equation of the relationship. So this shouldn't be anything new to you guys. Right here we have the different coordinates. In other words, at 5 feet away from where the steps start, where the handrail starts, the height of the handrail is 7 feet high. And then when you get 10 feet away, the height of the handrail is 11 feet. So let's talk about that for just a second. Write this down somewhere in your book. This is the horizontal distance. Our x value represents the horizontal distance. I'm just going to abbreviate here. Comma. And then the y value represents the height from the ground. Okay. And so this is my x, and these are y values. Okay. And then we have them plotted right here on the graph. Okay. So then it says, let's try to figure this out. They lie on the same, what do you think goes in here? They lie on the same, if you were to guess, what would you say? Line, right? They're on the same path. I like path. It's a good one. But they're on the same line. So the relationship, in other words, if I were to connect the dots, doesn't that make a straight line? Yeah? Okay. So, and it probably comes out to about, if I just follow the straight line, it probably comes out about right here somewhere. Okay. So the relationship is, because it's, yep, good, linear. Because it's a straight line, the relationship is linear. It says draw a line through the points. It's not proportional. Oh, man, that's good. Why is that? So you guys might not be able to hear this on the microphone, but the kids in my classroom are going, it's proportional. No, it's not proportional. Why is it not proportional? Yes. Yeah, it doesn't go through the origin. If it was proportional, it'd go through here, but it doesn't. It has a y-intercept, probably like 6 or 7. Okay, or no, wait, that would be like 4 or 5 or 3 or something like that. So it says draw the line through the points. Now, what they want us to do is to find the slope. So they're going to say that this is x sub 1, y sub 1. This is x sub 2, y sub 2. And so remember, the formula for slope is m equals y sub 2 minus y sub 1. And I want you to write this down. I know what you're thinking, Mr. Adams. I know this formula. Why would I write it down? Well, you know it today, but when we take the final exam in June, will you remember it then? Yeah, you have to take an exam. So the reason I make you write down the formula every single problem is we said that we have to see it and process it in our brain at least 27 times for short-term memory. Long-term memory, it's more. So you notice Mr. Adams doesn't have any notes. I've memorized it, well, obviously because I do this every single year, but I memorize it because I've repeated it and repeated it and repeated it. So I want you to remember it too. What's y sub 1? What do I put in here? 7. And what goes here? 25. Good job. All right. Now remember, you guys are participating, but no shouting out names. It's pain. I got to edit it out. So what's 27? Or I'm sorry. What's 23 minus 7? 16. Okay. What's 25 minus 5? Maybe that'll be easier. 20. Now I want you guys. This is a little bit of a challenge for me as a teacher. Your textbook sometimes wants you to leave it as a decimal. Sometimes they want you to leave it as a fraction. In this particular case, I know because I have the answer key on my other screen. Let's take 16 on our calculator and divide it by 20. Yeah, it's 0.08, so let's put that there. Now, the reason I know they want it as a decimal, the reason I know they want it as a decimal is they didn't put the little fraction line. So now what I need to do is I need to plug in an x and a y. What goes here? What goes there? What goes in front of the x? The slope. So what's the slope? 0.8. And this particular problem is 0.8. We just calculated it, silly gooses. All right. So now this is an x value. Where'd we get that x value from? Yeah, this x value. What goes here? 7, because it's y, right? So now what is 0.5, or I'm sorry, what's 0.8 times 5? Do it on your calculator real quick. Race, you go.
4.
Yep, it's 4. The 4. All right. So now what do I do to get b by itself? Yeah, I'm going to subtract 4 from both sides. Well, which is it, 3 or negative 3? 3. So now what is my equation? Y equals 0.8x plus. Oh, man, you guys are smart.